Hello, everyone, and anyone who is in the chat. Just going to give a couple more minutes for anyone else to join, and then we'll get started on our live demonstration. Okay, I think we're about ready to start. So thank you to anyone and everyone who's joined. This is a first time for me, first time for Vision Nav doing this sort of thing. But we are going to be demonstrating today three different types of AGV, automated guided vehicles, for you today. I'm currently sat in a cold warehouse in the Netherlands, so forgive me for wearing my puffy jacket, but needs must. So as I said before, we're going to be demonstrating three AGV. We've got a reach, a stacker, and a slim stacker. My name's Will Carder. I'm the UK manager for Vision Nav Robotics. Just make sure we've got everything in frame there. Okay, so yeah, we'll get straight into the presentation. So if anyone can, if it is possible to send, great. We've got someone coming in. Hi, Juan Martin. Nice to see you. Thank you for joining. So what we'll do, we'll start off with, I'll give you a quick presentation, quick introduction, very quick, and then we'll start the first presentation with this reach truck behind me. So I'll get out a shot so you can see that running. I'll be talking over the top of it, and you can fire any questions at me kind of whenever you want in the chat, and I'll try and address them as I go. So here we go. Yeah, as I said, I'm Will Carter. I'm the UK manager for Vision Nav Robotics. I'll give you a quick introduction to what we are all about at Vision Nav, in terms of our automation, in terms of our technology. But we are a global supplier. We are a manufacturer and developer of AGV, automated guided vehicles, specifically and especially automated guided forklift vehicles. We do AMRs as well, but really our main strengths, and what we really excel at, is in forked vehicles, so handling pallets and stillages. As you can see here, we've got plant areas all over the world. We've got partners and offices in the Netherlands and US, and of course Asia, which is where we hail from. Said we are a manufacturer, and we 500 staff, and then 70% of those staff are actually in the research and development side of things. So we started in 2016. That's when the company was founded by a handful of PhD graduates in robotics automation. And really from there, it was very quick, the progress with the company, such as the technology and the development of what they were doing. They really started off with their first customer shortly after founding, and then secured some bigger customers. We also developed the Bright Eye system in 2018. So I'll get into what Bright Eye is. That's something which is unique to us. Really interesting piece of kit, and works very nicely alongside the AGVs, and I'll get into that in a bit. Then we had continued success and continued development with 5G technology into 2019. Obtained really importantly for the UK and European market CE certification, and ISO 3691-4 certification in 2020. Really important thing for us. And then we very shortly after that set up kind of basically a very small operation in Europe, but we've really expanded actually with successful customers, implementations since then. So we've been very productive and very successful in our endeavors in Europe and UK since we joined this part of the world. We've continued to obviously have continued growth and success, and I think our investments from angel investors is reflecting that, as you can see on the right there. So we've got over 1,000 vehicles. It's close to 2,000 vehicles deployed globally now. Most of what we do is in manufacturing. Historically, manufacturing lends itself very, very well to AGV automation. We've got nice repeatable flows, and it makes things, it's a natural application for it. But more and more with the technology and developments that we're working on with the vision aspect of things, hence we're called Vision Nav. With the vision aspect of things, we're seeing more in the warehousing space actually. So traditionally, the warehousing space has been quite difficult to do this kind of automation in, and the reason for that is really you don't have a nice repeatable scenario like you do in a typical warehouse. In a typical factory, sorry. So I'll get on to the core technology. So if my colleague Charlie, who sat beside me, can just basically press go on the system and the RCS, the robot control system, what you'll see is, I'll just get out a shot so you can see what's going on. You'll see the AGV takeoff. Now, I'll ask Charlie to turn on the audible alarms just for the time being. Now, it's very, very quiet without those, which is actually a danger potentially. But you might be able to hear just in the background. It's basically saying reversing, please keep away. So you can't miss it. You can turn off now. Thanks. Yeah, it's quite distracting actually hearing that talking continuously. But it's the alternative is basically you hear your forklift truck drivers honking their horns all the time, which is again proper practice. We don't do that. We have an audible signal. So that's actually the reverse direction that you're seeing it now. So when we're talking about AGVs, forks moving forwards is reverse, and then body forwards is forwards essentially. So again, it would be signaling alarms and saying that it's moving, saying which way it's turning. Obviously, you can see the lights on the floor, which indicate where it's going to be moving or where it is. We have a flashing light up above. We have an and-on system or traffic light signal, some people call it. And we've got e-stops either side of the vehicle as well as inside the actual cabin as well. So you might notice a wall of boxes, which was very neatly stacked up by my colleague here. And what we're doing is we're representing an aisle, a typical aisle scenario. So this is a 3.3 meter wide aisle, which is basically the narrowest aisle which this particular vehicle can operate in. As you can see, it's got a turn. You can see how close it gets to the wall there. So it's now traveling upwards, and basically part of the mapping and the teaching is we have to teach the robot the locations into which it's going to store. So I'm just going to move that up. So this particular one is only about 4.5 meters tall. It's a kind of a second tier storage rack. It's a standard 2.7 meter wide rack, which we're going to be storing and demonstrating three Euro pallets to be stored side by side inside of. Now, you might not have any questions at this point in time, but I will address any questions which I, to be honest, get asked all the time. The same sorts of questions. One of those questions is, what if you stand underneath the forks? Obviously, everyone knows about the 360-degree. Not into that in a moment, but we do have 360-degree scanning, laser scanning, safety sensor around the machine all the time. But what if you stood under it here? It would be the same situation. So essentially, if I did stood up, I'm not stand underneath it. I'm not going to demonstrate it for you. But if I did stand underneath there is a safety feature in place. Now remember, all the time we would have the audible signals. So unless you were completely deaf and potentially as well, or just not paying attention, then you're very, very unlikely to get anywhere near it. But if you did, it would be safe. So it's done that first. I'm just going to move this upwards. There we go. So now the vehicle is going to pick up the second pallet, and this is just a routine which is being controlled by the RCS, the rubber control system, and place it in the second tier rack. So I'll tell you a little bit of spec about this vehicle. This is the VNR. This is a reach truck. This is one of many vehicles in our portfolio. It can be customized. Again, as a manufacturer, we have the luxury of being able to customize our vehicles to different types of payloads, different scenarios. You might have potentially an environment where a typical scanners wouldn't work. And I'll get into the scanning technology shortly after this demonstration. So I'll get into that in about 5 minutes about how the scanners actually work and the sensors actually work. This vehicle weighs about 3.1 tons. So you might be in a position where you have to consider floor loading potentially, but rarely. It's being the VNR 14, it's got a rated capacity of 1.4 tons or 1,400 kilos, which in Imperial is about 3,000 pounds, I think. But naturally, as we go higher up the mast, as we extend the load, the mast higher and higher, it can be spec'd up to nearly 12 meters. But as we go higher, we do have to be much more cautious about the weight of the payload that we're carrying. So that does naturally decrease. We do have a payload curve, which we got to refer to. So I'm going to keep that running in the background, and you should see in the small screen. I'm just going to go back to the core technology. So whilst that's running in the background, I'll kind of talk over it, and you should be able to um, see that working in the background. I think I've just clicked on something. Bear with me, please. I've changed the input somehow. Video. There we go. Thank you. So we'll just go back to the presentation and have that running in the background. So basically, I'll show you the output of this, the end of this kind of routine that it's doing. But we'll just go into the presentation again, if that's all right. There we go. Thank you. So the core technology, what makes VisionNav so special? You know, AGVs is a terminology which has been around for a long, long time. I've been in many automotive warehouses, automotive factories where you see AGVs running on the floor, following magnets typically, or sometimes barcodes on the floor. We don't need to do that. So we have no fixed infrastructure requirement for these vehicles anymore. And that's again with developments in the sort of the perception and positioning sensing that we're doing. So we've got four kind of pillars. We've got positioning, perception, motion, and scheduling, and I'll kind of go into those now. So starting off with positioning, you might see again in the background, and I will address it. You might see a QR code kind of just positioned on the top of the fence behind me. You might have picked up on that. And you might see in some of our reference videos on the left there a QR code. We no longer require that type of navigation. It worked. It served its purpose. So yeah, just you might be able to just see it just there. So just here, there's a QR code. We don't need to use that anymore. But it's essentially that was a way of navigating which has now been superseded by 3D SLAM. So I'll just go back to the presentation again. By 3D SLAM. So SLAM is a industry acronym. It's not a VisionNav acronym. It's an industry acronym. Stands for simultaneous localized area mapping. So really, it says on the tin to coin a phrase, but basically, it's using lasers to basically see the 3D space around it continuously. it provides higher accuracy, it provides higher adaptability, and it also means you don't need to have fixed infrastructure. Now, there are specifications of SLAM or 3D SLAM environment in which we're working. We might change that sensor, that particular sensor. That's probably the single most expensive sensor we have on the vehicle, but we might change it depending in a high ceiling environment, maybe in our environment with fewer things to reference off of. It depends on what the environment is, and that's what, again, what our experts, our implementation experts, are assessing when we go to site. So moving on from navigation, we've got perception. So another kind of really clever piece of vision navigation or vision perception technology is the perception sensors. So we have 2D and 3D perception sensors. So when we talk, you see here on the left, you see a 3D perception sensor. So basically, the sensor is positioned just behind the forks, and it's looking for the, let's say, the pockets, we call them, on the pallet. So positioned just sort of on this vehicle about there is a sensor which is looking for those features. That's telling it how far away it is. Is it the right height? Has it got clearance? Now, one question that I guess get asked a lot of the time is, you see wrapped pallets. Now, wrapped pallets can cause an issue. If you have plastic wrap around the bottom of the pallet, all the way to the bottom of the pallet, then typically that's something which will cause an issue because you've got reflection and the sensor sees a physical object. Sensors haven't quite got to the intelligence yet where they know the difference between a piece of plastic film which you can poke your finger through or a solid object. So in scenarios like that, that's not to say we can't pick up pallets with plastic film around them. There are scenarios where we can, but they're quite specialized in terms of, for example, we need to know that it's in a fixed location, for example. Now, in a warehouse like this, that might not happen. It might be a variable location, but in a factory environment, off the end of a palletizing end of line palletizer, that's more likely to be in a fixed location, in which case we can potentially have a solution where we don't necessarily have to worry so much about the pallet wrap. But he's just finishing off his routine now. The VNR is finishing off his routine. He's taken down all the pallets from the middle in this case. So you can see at the top there in the middle, the pallets come down and he's placed on the floor. Now, it is slow. One thing that you'll see is it's taken quite a while to do this. It's about 15 minutes, this particular routine. But the thing is, it's moving continuously. It doesn't need to take breaks. It can work 24/7. So the longer your operation, if you have 2, 3, 5 days a week, 7 days a week, more likely to get a good return on investment. Now, we do have customers who have return on under the 2-year mark, certainly when they start doing 2 shifts 5 days a week. So it's in the asset as much as you can, just like any asset you would buy for your business, whether it be a production piece of equipment or another manually driven forklift, for example. You don't want it really sitting around. So, but this is really what we do when we go into customers. We make sure that we can really make full use of the vehicle. So I'll just go back to the presentation again. So once this vehicle has finished off its routine, I'll show you another routine which is potentially even more interesting in my opinion, because it's showing 2 working at the same time. So we'll go on to the perception technology again, a little bit more explained with the perception technology. Another thing we do a lot of the time is automotive stillage stacking, or in this case, we'll show it's a wine and spirits stillage stacking, which is quite cool. So you might have seen lots of barrels behind me. We're actually in a customer warehouse, and we can stack some barrels. So these are actually unfortunately just filled with water, but we got some interesting things to demonstrate there. Bear with me just a moment. I just had a ping. I think I'm just double checking the chat. Cool. So a bit more, you can see here, we can handle automotive stillages. We can actually stack up to 7 high in automotive stillages or general stillages. It depends on the ceiling height. Most ceilings don't go that high, to be brutally honest. but destacking, stacking the stillages, and the machine vision, basically the camera in that instance, we would likely have a camera looking for the feet or the cup and cone location features on the stillage to actually marry up the cone with the cup on the stillage to make sure that all four have basically they're offered up to each other properly, and then we can drop it so that it stacks. So we're not going to be in a situation where one of them is potentially a little bit bent out of alignment, which does happen. Um, and basically, you know that the machine vision is also doing that check. Imagine you've got a pair of eyes right behind the forks rather than some guy eyeballing it from 10 meters away. Um, you've actually got a pair of eyeballs right behind the forks, which is actually looking for those features. So it's incredibly accurate, incredibly safe. You might notice on the right here we have these are basically this image is showing the two types of switches we use. We use switches at the roots of the forks, and these are detecting that the goods are actually fully on the forks. We can also change those potentially for photoelectric sensors, potentially if for whatever reason we don't want to use just a physical switch. And similarly, at the tips of the forks, we have another safety feed, which is basically again another switch. If you touch it, it will it will break the e-stop the vehicle. So again, another thing that we use for perception is bright eye, which I'll get onto in a moment. But it's another perception technology, which again is basically unique to us, and it's a fixed camera. So bright eye is a fixed camera which is fixed in a static location above or beside, for example, a marshalling location where you've got goods coming in or goods going out, and it will use machine learning or machine vision, sorry, to basically identify um, known objects in its field of view. So in this case, you can see um, a whole bunch of different palettes. If we go back to the presentation, sorry. Thank you. Yeah, in this picture here, you can see a person who might be working a supervisor, for example. You can see a forklift truck. You can see different goods. And if we look at the top left or the top right image here, we have basically a scenario where there are pallets stored in a marshalling area on the floor. Our robot control system can see those pallets on the floor, and it can actually use that information to trigger a task to an AGV to go and pick up that pallet or place a pallet into that location. So this is another way that we can actually monitor the inventory on the storage area for a number of different tasks, not only this marshalling, but you might even be sorting, for example, color sorting different types of empty pallets. Empty pallets is something which every single warehouse will have to deal with. This is something which is unique to us. So this is again, it's again, bright eye is a unique thing to us. Now, motioning. So this slide is really demonstrating that things don't have to be dead on accurate. I talked about a warehouse environment where, unlike a manufacturing environment, a warehouse environment is going to be um, it's going to be quite a variable space. You're going to have people dropping pallets here, there, and everywhere. Things aren't exact. So this is why there is a certain amount of tolerance within the perception technology. So basically, when we perceive something is out of alignment, that's sending a feedback to the AGV to reorientate itself or motion itself into a new position to pick it up in the correct manner. So you won't be picking things up skew-if and wonky. Basically, you'll be making sure that you pick things up straight, even if not necessarily someone has placed it on the floor a little bit out of alignment. So we do have tolerances there. So um, my colleague's just going to before we share the webcam again. My colleague's just going to go and move the pallets which the reach truck drops on the floor. Again, just a reminder, we can take questions in the chat. Again, it's a private chat, so I'll basically be able to see them. So my colleague's just rearranging some pallets in the background, and then I'll share my webcam again. It'll take about a minute or so. Yeah, so you might have seen a pop-up with a QR code. Actually, I got a question about booking demos. So I'm actually in our demo center in the Netherlands here. So um, it's about an hour south of Amsterdam. So you might just see a pop-up there actually. Um, Basically, you can actually book with us, myself, one of my European colleagues. Where I've got colleagues in Spain, in France, in Germany, and also locally here in the Netherlands too. And you're welcome to book with us to come over here. We can also do proof of concepts where coming over to our demo center isn't enough for you. We can talk about doing proof of concepts, depending on what it is that we're wanting to prove. But we can entertain the idea of actually getting a vehicle to your site, because we recognize the importance um, of 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 buy-in, basically. So I'm just going to share my webcam again. Yeah, so we can, as I mentioned, we can do demos, and but we can also you can also send us product. You can also send us products. I mean, these pallets which that VNR was handling were actual customer products. So we have had customers send their pallets over here and say, "Can you demonstrate placing it onto a rack? Can you test doing X number of movements per hour, etc., etc." So we can do this. For you. So we do have this facility available in the Netherlands where we can basically take you here, or we can dial in remotely. You can send product here to us if you need to. Um, so that is something which is a really valuable resource to VisionNav here in the Netherlands, and it's a resource which all my European colleagues and in the UK we use. So I think what we're going to do is we're going to start off the next demonstration. So right beside me, I'm just going to turn the camera. Excuse me, my voice is getting a little bit hoarse. So what we're actually demonstrating here is, if you can, hopefully you can see all right. There's a bit of a backlight from the warehouse door outside from the sun, but hopefully you can see that all right. Is a VNP, VNP 15, and a VNSL 14. So the VNP 15, I'll tell you a little bit about that vehicle. It's a counterbalance stacker, so it's a counterbalance truck, so it can handle basically any stillage or any pallet, pretty much. It's got a 1.5 ton payload, 1,500 kilos. I don't know what that is in imperial, but we mostly work in metric over here. The vehicle itself weighs about 2.9 tons, so it's a heavy old thing. But so that is something you need to consider when you're if you have, depending on your floor conditions. Maximum speed of about 1.5 meters per second, so it's a bit fast, like fast walking speed, a very very brisk walk, or maybe even a jog. So what we're actually demonstrating, the reason why Charlie and I have said we want to demonstrate um, two vehicles working simultaneously, is this is actually being controlled by our robot control system. And I'll show you some images, and we can do a full demonstration of the robot control system. That is something which I can actually provide an interface to and actually demonstrate what you would actually be seeing. But essentially, the robot control system is actually demonstrating this here. So the scheduling system is taking care of multiple robots or multiple different robotic agents at the same exact time. So there's no reason why we couldn't potentially have the VNR, which we just saw doing its thing at the same time, but we physically have space limitations within this demonstration area. But what the Slim is doing, and this will be different depending on when we press start, or if someone walks in the way, or depending on the environment. So you won't trip up the system, basically, is what I'm getting at. It will orchestrate sending the right vehicle to the right place at the right time. So the Slim is being tasked with sorting situation where it wants to collect empty pallets from the end of an aisle or from wherever, and then stack them on the floor in, let's just say, some kind of a marshalling area or a storage area outside. One thing we can actually do with empty pallets as well, I mentioned the bright eye system, we can actually do color sorting as well. So that can actually detect different colored pallets as well. So that's a scenario we do sometimes see. So hopefully yeah, it's just going to drop it just about there. So all the while, whilst this slim robot's done this, the VNP has gone and picked up a stillage. So what you're seeing here is only 3 of our vehicles. We do have multiple vehicles. So I wish we could get one of everything over here, but there would simply just not be enough space. We'd need a warehouse 10 times the size. But we've got this small area here, but we do also have AMRs. We have tugger or tractors, some people call them, which can pull stillages. You see that more in kind of an automotive environment where you might need to go from a really big factory from one end to the other and tow stillages from one end to the other. So we do have AMRs as well. So there might be a scenario when I say AMRs, automated mobile robot or automatic mobile robot. That's kind of sits underneath the genre of AGV or automated guided vehicle. The AMRs, we call them AMRs because they kind of more specifically these smaller type of ones. They don't have forks. They don't have forks on them. They're a flatbed style robot, or they have a little turntable on top. I'm sure you'll all have seen various iterations of this. But what's important about us is we can control it all under the same RCS. We have customization available. And that's something which we can do. Again, we can orchestrate multiple different robotic agents simultaneously. So just going back to what's happening here, this VMP again is blocked by this VNSL, and he's waiting for it to get out of the way. Now the VNSL has got out of the way, the VMP can go and pick up the second stillage. The VNSL can carry on with its task of stacking up the empty pallets. A little bit about the VNSL. That is one. These are actually our 2 most popular vehicles. They're very competitively priced in their space. They're very high on customization as well. So the VNSL behind me right now, standard features are a 1.8 meter reach. So it could stack potentially up to 1.8 meter high pallets. It can be used to potentially on a low level rack, pick and place something off a low level rack. But we can also spec it with a longer mast as well. So with a reach of up to 3 meters. Again, with a manufacturer, we can customize these things. So it can be spec'd up to 3 meters. Again, similar sort of speed to the VMP. But really the safety features, the CE certification, the ISO certification is common across any vehicle that we do. They will all have CE certification. They will all have the same safety features. So they're currently just dancing around each other a little bit here. So, but managing the space quite efficiently. So this VMP is now going to stack up the other barrel stillage. Again, we want to demonstrate here that it doesn't have to be a pallet. It doesn't have to be a Euro pallet all the time. It doesn't have to be a square standard stillage. What we do is we essentially teach or we train the stillage that we're going to be using, or the carrier is the more kind of general term for stillage and pallet. We call it a carrier. So we teach the carrier into our vision system. So we're training that, and it's then looking for known features. So in this case, the 3D the 3D sensor or perception sensor located behind the forks on the VMP behind me. They're sort of located just about here. they are looking, they will be literally seeing what we see almost. It'll just be in a more pixelated version, but they're seeing what we're seeing. So they're looking for those known features in the exact same way that a human would look for known features and go, yes, that's something I know I can pick up. So this VMP is just getting out of the way now, so it's going to be sort of parked next to me. Again, this is kind of a trained parking location just next to me. I can't quite turn the camera quite enough. And going back to, why you would employ automation, what are the main qualifying features of deploying automation like this, AGVs? The main things really are going to be, it's what return on investment you're going to get. So I mentioned you could be seeing less than 2-year return on investments. That's very realistic, very reasonable. And obviously, it's a little bit of a scary endeavor to kind of jump into automation when you've just done it the old-fashioned way with manual forklift trucks, manual pump trucks for so long, or conveyors if we're in a factory potentially. But you don't need that fixed infrastructure. You also don't need to have 2 or 3 shifts, different employees each time. Their breaks, their errors, AGVs inherently, because of all the safety sensors that are on it, and because it is automatic, they are inherently more safe. They're doing very repeatable tasks. They never blink, so they're constantly looking 360 degrees around them all the time. They also have the e-stops. They also have the physical collision sensors. So there's so many fail safes with this. And I'll just go back into, I will go back after we've just finished this routine, I will go back in and show you some more safety features which are worth being aware of. I'll also talk a little bit more about the robot control system and what that's doing. But you're seeing the intelligence of the robot control system here in real time. Other systems that you might see might have vehicles which look very similar to this. That's all well and good, but what's actually controlling them is very different. The sensors that are on them are very different. They can only do, dare I say, much simpler tasks, A to B movements, whereas there's actually some intelligence, some orchestration, we like to call it. There's actually some orchestration between these vehicles. So we're only seeing 2 vehicles here, potentially 3 if we had the space for the VNR to work at the same time. But this could be 10, 20 vehicles. It could scale up. So basically, you've got the scalability inherently because it is a modular kind of system. It is a scalable system. Obviously, the benefits of scalable systems are that you don't have a single point of failure. You have redundancy built in. So another question I get asked about is things like charging. How long does it take to charge? Typically a 3-to-1 ratio. So 1 hour charging to 3 hours operation. Have a 4-to-1 ratio. Maybe an entire for base typically a shift. It's typically designed to run for an entire shift on pretty much full to low. Now we do opportunistic charging in between. So if we had these 2 vehicles running and they didn't have any tasks that they'd received from a WMS or the RCS, they would go off and charge, automatically dock with the charging station and do an opportunistic top up, maybe just for 10 minutes if they needed to. Maybe you could schedule in those charging times during a known downtime, if there is a break where no work is being done. But again, that's something which our solution engineers design into the system. They design in enough robots to have opportunistic charging. Now, you can actually remove the opportunistic charging as well. You can actually change the batteries manually. So the battery on that VNP, the big one, or the stacker, is actually quite a heavy lump, as you can imagine. So you do need like a special trolley to change it. But the good thing is you can do that quick change. It's almost like a SMED tooling, single minute exchange die, inspiration from from the mold tooling manufacturing. You want to be able to change the tooling very quickly so you can carry on going. Now with that battery change, you can basically continue production very, very swiftly. You can put in a fully charged battery very quickly. Obviously, we need to train you how to do that because it does require um, some care and attention. But typically, um, opportunistic charging is designed in there. So I'll just go back to the presentation, um, and I'll continue talking a little bit more about some of the other technology that we use, which I think you might be interested in. Um, trying to trying to change slide. Here we go. Perfect. So scheduling. So basically, what you would have is you would have we can schedule different. So when we actually saw in real time the scheduling of the vehicles, but essentially we could have AGVs, AMRs, different types of robots running around the place, and you would be able to control them and schedule them all with the same RCS. Just a little bit more about the safety because it is a really important thing, and I've got another piece which I want to talk about on the safety. But basically, we have a separate safety PLC circuit. Again, that's a machinery directive requirement. It's required for CE certification. You have the necessary e-stops, and again, anyone who's going to be working around this gets trained by us, just to basically know what to do if you see an orange flashing light on a vehicle, or you need to know how to do a basically an emergency stop. Pretty obvious. You would train the same stuff to anyone operating any automated equipment at all, anywhere in the world. You would teach them what to do in case of some unknown error. So, of course, we'll provide training to operators and to a certain engineering level as well. I mentioned additional safety features. We've got ultra wideband frequency. So UWB safety system, as we kind of abbreviate it to. Basically, this is a transmitter which a transmitter which someone can wear on, for example, a hard hat or onto a high vis vest, for example. Um, and what this is doing, you can tune the distance where these two, the transmitter and receiver, talked between 1 to 4 meters. But basically, this is just an additional thing, so the AGV knows that there is someone there if they come within that radius. Or you might want to give it to another forklift truck driver. If you've got a manual forklift truck driver, for example, driving a VNA vehicle, for example, you might want to give him this just so if he's zipping out an aisle, the AGV can see it before it physically sees it. It knows that it's there. So this is just a belt and braces feature which you can specify. Very cost effective, and very easy to implement as well. So again, a bit more into the kind of the what's going on kind of in the background, but is really, really essential to the solution that we provide is the RCS. So or kind of the structure, the architecture. So we can go over. Typically, we need a Wi-Fi signal, but we actually can do 5G as well. To be honest, I've not seen that in the UK or Europe so far, but it is something which Asia is employing a lot more, and we know for a fact that it's going to be used more locally. You'll have to deploy a local 5G system, but that's so essentially we're trying to demonstrate that we're essentially ahead of the times. We're getting ready. We're future proofing our automation ready for different methods of communication. But essentially, the RCS sits underneath the WMS or the MES, or the MRP, for example. It'll sit underneath that, and that's the RCS is basically providing the communication between the vehicles and to the WMS. Um, how we talk to the vehicles is we will be bringing out VDA 5050 protocol, but for most customers that's irrelevant, but for some of our automotive customers that's more an interest. Some of our integrators are interested in exactly how we're talking to the vehicle. But basically, we can do what we call a black box or a white box or a gray box even integration between the RCS and the WMS. So the way that that basically denotes how much your WMS is doing or how much the RCS is doing. So, for example, I might get this the wrong way around, but basically, the black box integration, your WMS would be doing very little. The black box integration, your WMS will just be sending us a task, whereas a white box integration, you'd be sending us a very specific task to a specific area of our piece of automation. But this is kind of industry terminology. you might have come across with other automation providers, but basically we can facilitate any kind of integration. And that's because we have different types of modules within the RCS, such as inventory management. I already talked about scheduling. Um, and the way that we talk is typically done over an API. So it doesn't have to be a tier one WMS like Manhattan, for example, or Blue Yonder. It doesn't have to be that. It can easily be an in-house system. I come across many customers who have an in-house built WMS or even MRP, and it doesn't have to be an off-the-shelf one. You can build it yourself as long as you can provide us with an API. We can talk to it. I'm just going to turn my camera back to me. So there we go. So yeah, a little bit more about that. In terms of integration, we would have the vehicles, we would have the bright eye, all controlled under the RCS. And then other automation equipment as well. You might have, for example, a pallet wrapper, which we need to receive integration from. We need to receive an instruction from. A task is triggered by that pallet wrapper, for example, a pallet going to the end of the conveyor. Pallet is ready to be collected. We can integrate with that as well. So we basically just need the correct outputs. If we need to do some level of modification to that, there are certain things that we can do. But typically that is something that we can integrate with. So whether that be, again, I mentioned ASRS systems, it might be, for example, an auto store system or a big Schaefer ASRS. It might be end of line pallet wrapping situation, or maybe you've got drinks or food or whatever it is coming off the end of a pallet and you want to take it into end of a conveyor. You want to take it somewhere else. Doors as well. So there's whole things that, as long as we can provide an output or receive an output. These are some of our vehicles, but not all of them. So we've got the T series, which is just a pallet jack. We are bringing out a new pallet jack as well. So I want to express that we are developing new vehicles quite frequently. So we're not only new vehicles, but new features on our existing vehicles as well. So we're constantly updating and customizing because our customers present us with challenges, which we then, try and tackle. So essentially we've got pallet jacks, we have stackers. You already saw the slim stacker today. So that's a very popular vehicle for us. It's compact, it's very cost effective, it's compatible with any open style stillage or pallet. You then saw the reach truck as well, of course. That comes in different iterations, up to 2.5-ton payload, up to well, I said before, we can actually go potentially even higher, but that's a special customization than 8 meters. Counterbalance truck, you might use this again if you've got a high payload, or if it's maybe the floor is a little bit uneven, or you've got some ramps to deal with, or even you want that redundancy to be able to drive it manually if for whatever reason you need to do that. We also have the P series, which we demonstrated. That's probably our second most popular vehicle, or maybe is joint first popular vehicle with the Slim. Again, it can be spec'd up to customized up to 4.5 meters potentially, but typically up to 3 meters. And then we have the tow tractor. This is, or a tugger, as some people might call it. This can this is typically used in large manufacturing plants. But we also have AMRs, and we have some new vehicles coming out as well. So this is just a nice exploded diagram of the vehicles. And what I'm trying to show here is the fact that we've got the control module, which is basically, you'll see a box which has got the HMI on it. That's where that's typically what our engineers use. You guys typically wouldn't use that, but we have an HMI or user interface, as some people call it. We have the LiDAR sensor, or sorry, the 3D SLAM sensor is positioned typically on top, and then down below we have the SICK sensors. The SICK sensor, again, provided from SICK. Those sensors are positioned on the two corners of the vehicle, and they provide a 360-degree view of the area around it. So that's a separate safety circuit. So, and then we've got the perception sensors, which are typically positioned just behind the forks. We've got about 15 minutes, so just in case there are any questions at the end, I'll leave 5 minutes or so, 5 or 10 minutes, and if there aren't any questions, then we'll wrap up. But hopefully I've addressed the majority of questions which could arise. I tend to get asked the same questions most of the time, so hopefully I've answered anything. But if you do have anything, there's an email address down below, or you can contact myself on LinkedIn. That's William Carter. Again, we can field your questions anywhere you are in the world, anywhere you are in Europe or UK. We can field your questions to the relevant person, whether it be a technical question or a commercial question about pricing, about how we integrate. So yeah, feel free to get in touch at any point. Um, but we talked about the RCS. This is kind of what you would see actually with the RCS on your kind of dashboard. So we can actually customize these dashboards, and importantly, quite a lot of our installations are done with partners. So when I say partners, I mean systems integrators, and sometimes these incumbent systems integrators might have their own system. They might have their own um, warehouse execution service or warehouse control system. Um, if need be, you can continue using that existing business logic. You can continue using that interface, and we can sit below that. But essentially, our RCS will still be running there, and it will still be actually controlling and orchestrating the robots. That WCS will basically just be sending us instructions via from your wife WMS. Might have just seen a question pop up there. Yeah. So in terms of a question about the complexity, or is there really a requirement for the RCS? Essentially, yes, there is a requirement for the RCS. It is needed to actually receive tasks from something and send it to. It is your translator, if you will, between whatever is sending the tasks and then sending it to the AGV. Now, we don't have to do a fully integrated system. We don't have to do a fully integrated system. And that, if that scares you, if calling up Manhattan kind of scares you, because essentially they can be really expensive and daunting. Big company like that, they do cost a lot to bring in, and maybe if you need them to do any modification to your existing WMS, they could cost you a lot of money. Now, there might be a much simpler process that could be done if it's a very simple task. If it's a very repeatable, simple task, you might just want to use a call button, for example. It could be triggered by something as simple as a go button, which we just put onto a tablet or a handheld device. Or it could be triggered by something as simple as a photoelectric sensor on the end of a conveyor. Once that sensor is tripped by the pallet, the AGV comes and picks it up and then places it somewhere else. So simple integrations are possible, but we're seeing more and more these more complex situations where you are needing the AGVs, because it's typically a fleet, the AGVs to do more complex tasks. And that's really where the intelligence of the RCS comes in. So this is over and above what some other AGV suppliers use. So if we get lumped into some AGV suppliers, they might do simpler AGVs integrations, which are just simple point-to-point movements. We can do that, but over and above that, we can offer the ability to do much more complex integrations. So again, such as the development that's gone into this robot control system. So again, these views they do have certain customization available to them, but you will be able to see things on your dashboards from your kind of your central server, from showing things like the battery life of the AGVs in the fleet, where they physically are. There might be certain KPIs or performance indicators which we teach into the system. So, for example, you can see some pie charts down below there. How many pallets, how many tasks has it received? Does it have a live task? You can also edit the tasks. For example, if for example, an order priority changes, you can actually live change the task's priority if you need to do that. So you've got the full customization, and we can demonstrate this very well if need be. So I don't think there are any more questions on the RCS, but hopefully that's addressed most of the questions that come up. I've tried to kind of foresee everything, and that the questions that typically get asked. Unfortunately, I can't see you guys, but hopefully you can see and hear all the questions that I'm trying to answer ahead of time. Um, and really, in terms of contacting us, just wrapping up there, you can contact us anywhere in the world. We have offices in the United States, in two locations. Of course, um, Asia is very, very well covered. We have thousands of robots installed over there. Our European operations is growing very rapidly. In the 1.5 years that we've been situated here, it's grown very, very rapidly. We got orders with customers in spaces in logistics and manufacturing and automotive and general manufacturing. So next year is going to be a very, very busy time for my colleague Charlie here and the installations team. So if you have any questions, you are welcome to contact me directly. Info@visionnav.com is another area where you can contact me. And finally, the final question, which I do often get asked, which I've just thought of right at the end there, but I don't have a slide on it, is about after sales and service. So typically we do want to provide you with the ability to keep your vehicle running. We don't want it to be broken down waiting for us. So we will typically provide you with a spares kit to be held on site. Now, how big or small that spares kit can be discussed, but essentially we think it's very advisable to hold spares on site. Now, if you have any other pieces of automation, whether it be packaging machinery, conveyors, typically you will hold something. Now, critical spares we would advise to be held on site. You take care of it as if you would take care of any other parts. We do PPM, so planned preventative maintenance, is scheduled in at least in the warranty period, and that can be extended after that warranty period as well. But PPM is scheduled in twice a year, typically. So we're looking at things like, the any on the wheels, obviously greases and lubricants, all that stuff's done. And then when it comes to actual breakdown and service, if you do have issues with the vehicle or issues with the RCS, we can dial in remotely. We do have we do have remote offices hotline which you can call, and typically will be able to answer your questions pretty much over the phone straight away. So that is a service we can provide 24/7. And then if you do need anything to be done immediately, as I said, you've got that built-in redundancy. So you do have a modular system which is built-in redundancy, and you do have the critical spares on site. If you need us to get to site, we can arrange getting into site. We do have local partners as well who support us in that regard as well. So again, as I said before, most of our engineers are from Asia, but we do have partners in the US, we do have partners in Europe, in the UK, who can support us on the ground, that very quick response if we need to as well. So we've built up some very good relationships. So rest assured, whether it's planned preventative maintenance, spares, hotline support, or corrective maintenance, breakdown maintenance, then we have all those covered essentially. So that's all dependent on your scenario. You might not need 24/7 cover, but and essentially your fleet might be big enough, but that's something that we can do as well. So that's a really important thing. So I think just finally, if there are any more questions, you can throw them my way now, or you can throw them our way at any time in the future. You can contact us on the email that's been going along at the bottom there below, or you can contact me directly. But if there's nothing else, I will call it a day. Thank you very much.